everybody, this is Itsu once again. I was intrigued by my ceramic decoupling caps going up in flames across my battery a few times. That I was looking into this stuff. Something is happening at the battery side, which should be very stable, especially when you have these decoupling caps across it. So I came up with this diagram, very simple. I have the two batteries in series, 25 volts on the left. I have an amp meter going to a big 50 watt resistor, going back to the return from the battery. Ohm's law says that we have a 1.13 amps running to this circuit when I attach. We will see that on the meter. What I did here, I put an AV plug in this configuration to earth because my batteries are grounded. What I would like to do is to see that this circuit is behaving very normally, but when I later on substitute this resistor for my cacher, something completely different is going to happen. Very likely because of the RF radio frequencies having some influence on the batteries or the circuit. This is the circuit here. I have the multimeter across the batteries, it's almost 25 volt. I have an amp meter here, and this is the 220 volt, I think 50 watts resistor. And here we have the AV plug. I have a 40 microfarad cap, and I have one side to ground. And the ground is coming from my water line, water pipe, my plumbing. So it should be real ground somewhere. And this is the voltmeter across the cap. It's 0.8 volt at the moment. Okay, I will attach now the resistor. You can see we have the 1.13 amps running almost to the system as predicted by Ohm's law, and there is no voltage increase across the cap on the AV plug. I have 24.8 volts, so we have some current running, no DC, pure DC, no AC at all. Okay, what I now will do is to change the plus and the minus across the resistor to my cacher, and then we can see what's happening then. Okay, welcome back. So I removed the resistor here, and I have attached the ground to the ground emitter of the transistor, and we have kind of this circuit now. I found it on the web a few months ago. These values are not correct because I still have my 40 microfarad 500 volt caps here. But this is a cacher in the same configuration I have now here. I will now attach the plus of the catcher, and you will see that the amp meter goes all the way because it draws about 1 amp, 1.2 amps. But we will have to look at the voltage across the cap. You see, I already did some test run, and it's now already at 40 volts. So I will attach now the cacher, and you can see in a very short time this cap is loaded to 164 volts. It has some influence on the meter, so I have to watch out not to exceed the ratings of the cap. And it's already at 230 volts. So yesterday I had a gas a spark gap and a bulb across it, and it started to flash. But you can see that in this configuration the HF, a lot of HF is coming somehow into this battery environment in this cap. So probably that's what make my caps go up in flames sometimes. I'm not sure how I can use it. I will try to hook up a lightning arrestor to protect the voltage from going up too high, and a bulb to see what's happening then. Okay, here we are. I have attached a lightning arrestor in series with a 25 watt bulb across the cap. So we have some protection. It will fire at about 400 volts. I will now start up the catcher and see what's going to happen. We are 400 volts now. 500 volt. Now it flashes. Try to see them both in the same. We are 300 volt again. Almost 500 volts. And there it flashes again. So there's a lot of power coming in this circuit. We see that the voltage on the batteries are rising. 26 volts. Instead of the 24.8, which it really is. So I'm not sure what's happening here in this circuit now. The cache is a little bit streaming. So I have to disconnect now, and so this is the circuit I'm using at the moment. I will try to find out if I still have power enough to load a cap coil, which I did before when using this this power. I'm not sure where it comes from. Okay, all connected now. Both load here at the back. The battery cap is charging and flashing. I have almost no streamer anymore at the top. No streamer at all to be seen. And I have a cap at the back side. I call it. I'm running out of meters, so I hooked up my my analog meter. You can see it's climbing up to 500 volts, but it takes a long time. And then it finally fires, I think. There it was. And then it goes back. But it takes much more longer time than when I have not this contraption at the battery side. So I guess the power is still coming from the cache, because we have 1 amps at 25 volts. It has to go somewhere. Okay, time to think it over and see what it's all about. Thank you for watching. Okay, just to compare, I have removed this battery AV plug circuit. I have now the basic battery 24 volts, 27.7 volts going into the cache, and I have the load at the back end, I call it, with a 60 watt bulb at the moment. I will put on the cache, I have now again a streamer on the and we can see that it takes still some time for the cap. There was the discharge. It takes some time, but it's faster than it was when I had this other thing, the other bulb connected to the battery. That was again. So compared with this, it's much faster charged. So we lose some power when we have this contraption at the battery.